This is December 11th, 2015, and we're here at EPD Laboratories with Eric Dollard. And as you can see behind Eric, we do have there was a lab coming together with equipment and some experiments on the bench with the network system that's related to the seismic project. And if you haven't seen the video on that yet, that'll be on YouTube, where Eric goes into a lot of detail about what this is about. But anyway, we can see some of the equipment here. And do you want to kind of explain what some of the equipment is and how you...
Well, this is kind of the network test bench where I test the response of various transformers and coils. These are the things that I've stripped out of equipment so far.
All of these?
Yeah. And there's boxes of other things around. So this is kind of all the stuff that's being stripped. The strippage has produced enough components that now at least I can start to kind of throw some stuff together. So there's various pieces of test equipment that came from different locations, and there's some people that have donated quite a bit more test equipment, which has helped. So
there's the
some of this stuff is from like Mark McKay, and then some of the stuff popped up around here, and then some of the stuff was on GLOM runs with me and Steve Hills, and like this oscilloscope was in a pile of debris in some place, and Steve came back with it, and we dumped it off here, and most of it was junk, but there was a working oscilloscope.
Right.
So that helped a lot.
So
it's all kind of coming together now that I got enough test equipment where I can at least start to do some experiments and fix things.
Okay. Can we take a quick peek in that room?
A good share of this stuff is supposed to be stripped. There was a bunch of equipment that was in storage on the coast, and when we went back to get it, we found out the building had collapsed and most of the equipment had been destroyed. Like this stuff here is all rotten out, and so
right now here there's a sewer problem where there's a drainage issue and the sidewalk is tore up outside, and the city is kind of giving some assistance. So
can't use any bathroom. There's no bathroom here to wash or do that stuff. So I'm really having a good time.
And so Justin is spending a lot of time dedicated to that project, because that sewer has to get fixed, and as soon as that's done, then he can get back to doing some building around the shop as far as putting up shelves and that kind of stuff. So we can
is beyond us. It's out of our control. So it's become a major public utilities effort. So there's no resources for a long time. So pretty much, then I guess we'll be getting back on getting the infrastructure in here, because the weather's so bad outside. We can't really do a lot of line work. We were really fortunate that other day just to have that 1 or 2 break where you could go out and you could have Steve McGreevy come and connect his radios to it and all that.
Right.
But it's not like that outside right now. It's mud and snow, 29 degrees, massive windstorm came through yesterday, and everything's covered with dust. So
we can take a look at that bookshelf there.
Yeah, this was these are what are called the Bell System practices. So the diagrams of the setups of their carrier equipment and microwave facilities, and how the whole fiber optics thing evolved, and everything is all in these books. So you could actually there's so many of these things, you could fill 4 of these buildings to capacity with them. So this is,
if you had the entire full
set. Yeah, they use even Bell System practices for how to put the Christmas tree lights on the Christmas tree in the offices at Christmas time. They're very thorough. So I have half of the basic important technical ones, and then Phil, with his telephone exchange that's shown on the website, he's got the other half up at his place. So I have to get up there and bring all the numbers of these and compare the numbers that we got, so I can make some kind of index list. And I'd like to get this stuff on the website, but that's another detailed project. Yeah, so most of the equipment on the ground here is this is kind of the stuff that's being fixed up and going to be put into operation, and then
So are you actually getting some of the same equipment that, like what you used at Landers?
yeah, a lot of the Lander stuff is like the Navy frequency counter.
Okay.
It needs work. I'm not going to fire it up until I get the electrolytic capacitors changed, but it's intact. The Navy oscilloscopes, there's so far one out of the pile that works. There appears to be another that's repairable. So that's building up, and then there's some equipment that's in really bad shape, and then there's this fancy stuff here which allegedly is all working, but the complication is it's all computer, and I don't really know how to use it.
You have to get some manuals printed for that.
Yeah, and even the manuals, so this one here is beyond me. But this one here, this is the receiver for the generalized receiver for connecting to all these antennas and transmission lines and everything else. It's called a selective voltmeter, so that's a very important tool.
You probably didn't think you were going to see this stuff again.
Well, I never even had anything like this. I used the older stuff. So I did GLOM a lot of the older stuff.
But this will do the job.
Yeah, and this master oscillator, basically it started, I just needed a basic radio signal generator, kind of like an audio one, but then these things showed up, and I'm going, well, they're too complicated for that kind of work, because you got to have a knob and all that. But then I'm reading through the book on the thing and find out that this thing has a precision that is unbelievable. It's actually, it competes with the National Bureau of Standards. So this is going to be very good for studying like power line frequency drift and setting the carrier oscillators, the master oscillators, and a lot of this other equipment. But as far as troubleshooting goes and all that, I still need one that's more like this variety here. So the digital is really no good for this kind of stuff because you have to sweep. And this thing here is reading the frequency, but it does it all by itself. It's so complicated I don't even know how to use it. But all I know is when I turn it on and I hook it to it, it gives me the frequency, and that's what I need. But it probably does all kinds of other things. I have no idea.
But it does what you need it to do.
It does what I need it to do now.
Right.
Reluctantly.
Yeah.
Because it's digital, you don't have any control over the voltages or anything anymore. So the problem is when the voltages get high on this stuff, it freaks it out.
It overloads it.
It overloads it, yeah. This is going to be what I call the music television. Well, it's not really set up to do much anything with now without connecting more stuff, but that's where this setup I have that takes music and converts it into an image on a TV screen. This was a very lucky find up at Mark McKay's place, was to find an oscilloscope that's based on a television tube instead of a normal oscilloscope type tube. So it's got the necessary video and everything that comes with the television that's required to do the music representation on the screen, which is really hard to do with the regular type of oscilloscope. It's next to impossible without some severe modifications. So then we got these, which are in an unknown condition, but these are going to be the front ends. This is what's going to connect to the telluric antennas as the input. So these have, they're designed to measure levels of noise in telephone and carrier communication systems, so they have all the necessary filters, and plus the thing will amplify 1 billion times. So it's so sensitive that connecting this to the lines, I can get an amplification up to a normal milliwatt level, which then can be sent down a normal telephone line or whatever, or connect to other terminal equipment. So there'll be one of these for the overground and one of these for the underground. So every receiving system will have a pair of these. And then these couple into the original setup we had planned to go in the cabinet is a pair of Altec public address amplifiers. And they're made to run on station battery, just like this thing is. And you don't have to plug them in. They'll run on the DC power system. So this thing puts out enough signal to drive that. And then we have two big outdoor RCA outdoor loudspeakers where then you can hear this stuff around wherever, pole or whatever this gets installed on. So most of this is going to be in a cabinet mounted on a telephone pole somewhere to start with. And then I have a portable version of this, which was shown in the video. This was very light to find. This is the carry-around variety. We were using it to listen to the power line hum. This thing's very sensitive. I can't believe that one of these things even showed up, but it did. So this is kind of the same thing, and then it comes with a little headphone that you plug in, and then you can listen. And this was, we were operating this in the video. So what's nice about this is it has all the filters, and it has the amplitude headroom to amplify the earth signals without introducing any spurious noises or overloads or any of that kind of stuff. So this thing showed up in a junk pile. I would have easily paid $1,000 for it. That's how valuable it is to me. So of course all this stuff comes non-working. So there's a little bit of a fight to get this thing to operate. But got it operating, and then as a bonus, in the last GLOM up in Wendover, I got another one with a military case on it. So I have to fix the battery cables, and there's a little bit of transistor noise, or maybe a capacitor. So that's pretty good there. So, and then, so we managed to acquire 5 miles of this field telephone wire that we can use for the antenna structure here to start with. So that was a very good GLOM. So I think we have 20 some odd rolls, or
So it's a single wire from end to end?
Well, we're going to use each one of these pairs as one conductor on the glass insulators. So we'll use each pair as kind of like, here's one here that's got the termination on it. So there'll be a pair of these for every carrier pair. So we're going to use this as one wire. But being that they are pairs, they also can be, used for further transmission experiments. So on some parts of it, each lead will be brought out as a pair. So there'll be six wires required for 3 pairs. This is going to be a pair. I don't know if we can get the camera kind of vague. But that's what the cross arm looks like when it's done. Okay, closer to get a...
And that'll be... But it's not going to be that many wires across, right?
Yeah, it's going to be
it is going to be like that.
Well, this one actually has an extra pair on it. We haven't taken the pair down yet.
Okay.
But most of that stuff is on the website.
Right. Okay.
So we have the wire, we have most of the insulators, and most of the cross arms and the things to fasten the wire. Yeah, here's something we got in the telephone GLOM from Wendover. I don't know, I can't find this in the practices on it, but we got all kinds of even fancier test equipment out of that. This thing is for measuring signaling frequencies and dial pulses, but I don't know exactly how it goes about it, but it's a very sophisticated piece of equipment. It's a work of art, if nothing else. So I have a number of these test sets that perform a lot of useful functions. So they're the same genre as all these types here. So there's a big load of this stuff. And then I've got 7 PRC-47s that don't work. So I can say that's the big disaster right now. I don't know really what to do at this point to try to get a working PRC-47 together. So if anybody can perform a miracle of getting me a PRC-47 that actually works, preferably 2 of them, that would sure make me feel a lot better. Because a full day of labor was spent on these things. 3 of them were bought that allegedly worked, one by you, and then, no, 4 of them. 3 by us and 1 by you, and all 4 radios were no good. So the one in my car won't transmit, and I can't even get one good module out of this many radios to get the car to transmit, so I'm not happy about that.
Let me go over to that stuff over there.
Go to this pile here. Well, there's various piles that make it so you can't walk. You have all this stuff, so this stuff just comes in bulk. So, some of it's useful, some of it is junk. We're going to try to find ham radio operators or whatever, that can take a lot of this stuff. That's not going to be used here. It doesn't have any useful parts. I don't really like throwing it away, but at some point I think I'm going to have to. So all this stuff has got to be sorted out and processed, and then we have to find a way to stash stuff that may get taken apart in the future, which will have to be external to here. There's really no room anymore.
So there's a few chart recorders over here. Are those?
Yeah, I'm starting to accumulate the chart recorders. We have no building to put any of the receiving equipment in, so it's going to be a while before these things find their way into some kind of signal environment. But at least we have the materials. But as I pointed out when we were out there in the field, is we have to have that terminal building in order to really get anywhere with any of this stuff. So this is more telephone GLOM that came in, and then radio transmitter GLOM is buried by other GLOM, so you can't see that. So these are the regular carrier voltmeters, but they all need to be repaired. So I'm hoping I can get one of those together. They're not digital. They don't really go down low in frequency like the fancy one does, or higher, but they're simple. And then these are another version of those signal measuring sets, like the one in the box and the one that I put on the bench that we're going to use as receivers. I think these things are probably get one going, and the rest are for parts. There's a lot of useful transformers and stuff in there.
Okay.
Then the big score was, it's pretty much partially buried in debris, but was to get 4 fairly complete Western Electric carrier multiplex telephone terminals. So what these things do is they take 4 telephone circuits and they put them on 1 pair of wires. And then there were 4 bands. So this system in its entirety would, on 1 pair of open wires, it would put 16 circuits. So I never thought I would see one of these things complete ever again in my life. Phil's telephone exchange, I got his working for him, which oddly enough came off the very wire lines that we're salvaging now. So I went there and got that working for him, and then our telephone GLOM at Wendover, I found a whole bunch of these, and then we went back and did an organized removal and found that there's 4 complete systems. Other than some hardware and stuff, so it's missing, but I'm only after 2. So the whole idea is we have to eventually transmit the signals from the terminal building out at the mine to the town office building and museum, which is a considerable distance. So we have to put 25 poles up if it's going to be our own line, and that's just beyond conceiving as far as cost and time. So we'll have to lease a pair from the phone company, and then these things will multiplex that pair so that we can get 4 voice frequency channels in the one location. So those will have the seismograph tones multiplexed on them and sound of the earth signals, and then one of them will probably be an actual real telephone circuit, because these things handle all the dialing and the supervisory. They're complete.
Are these racks behind you what all this equipment goes on?
These racks here are basically right now to get the more expensive test equipment and the stuff we need to actually use off the floor and up where we can start working on it.
Boxes of tubes.
I have like thousands and thousands of capacitors. I don't need that many capacitors, but at any rate, I got them. They're useful when doing this network study because usually these networks use 30 or 40 capacitors at a time. So there's lots of them here. In using up a certain amount for experiments and screwing them up, at least I'm not destroying a parts inventory because I have about 1,000, 2,000 of each value.
Are there any particular pieces of equipment that you're looking for right now that's not?
We're pretty much set. It's pretty much all here. So we got the main thing. Let's go over to the other bench here and I'll show you. Then at some point I'm going to have to order a bunch of toroidal cores to wind these loading coils on because these are not the right value. But that's not a terribly expensive thing, but I'm not quite at that point yet until I finish these experiments. So that's kind of on standby. And otherwise the bulk of it is, trying to find the parts for the car when something takes a squat. That's not very easy anymore. So I've been fighting that. So I say basically the main thing that's needed right now is lumber to build the storage facilities out of.
So for shelving, for example, to get some shelving in here, what would that be, a couple $1,000s in lumber to? Yeah,
well, there's the shelving and then the benches too. So there needs to be more benches and there needs to be like shelves underneath the benches. And because, one bench is usually dedicated to something, so when you want to work on something else, there's no place to work on it. So.
Yeah, so maybe about $3,000 or so.
Yeah.
Okay. Yeah, I'm going to get a jacket on and maybe if we can go out back and talk about all that stuff.
Probably all covered in snow by now.
Okay, so we'll go out back behind the shop and quite a bit of equipment that's actually for putting up the seismic lines.
Yeah, most of this stuff now is out and up for the most part. So we have to get our insulator count together. We got cases here filled with insulators and pins and all that. We're going to need, like I say, over 200 insulators. Some of this is from the salvage project we did, taking the abandoned Army phone line down for the water department. So that's like all these insulators, but these aren't the kind of insulators we can use. We got quite a few cross arms out of it. Most of them were completely rotten, but we did get enough of them to help put the stuff together. Here's the coax we took down, so that's kind of useless to us. It will eventually go to the scrap yard. But and then we got all this iron wire that came off that Army line, and that's not, we had to cut it all up. It was too difficult to manage. That's not really worth anything, so that's probably going to be scrap. We got doing pretty good on the poles, so we basically have all the poles that we need to finish off what we're doing here. The ones that were shown to be missing from back there or rotten and had to be replaced, we got everything there. So all in all, material-wise, we're doing pretty good. Here's the repeater cabinet. Not in very good shape, so you can see the gun heads have shot holes in it. It does have the racks inside and everything. This was an original N-carrier telephone multiplex system. The repeaters were spaced every 8 miles on a pole, so we got this one off the pole. So this thing's going to go to the auto body shop and then have them take care of this stuff and get it painted. And then we got to find this special fitting for the door. And this is going to go out there at the Mojave, the one that's 200 miles away from here, the other antenna structure where the wires are already up. So, and then we'll put some of the stuff that I showed inside will go in this cabinet, and then that line will be basically operating as a receiver. Then the next step is to figure out how to get the signal out of there. So we have to lease the space in the telecommunications building that is nearby, and so that's all going to be another expense and logistics and whatever. So the best we can do is just get it to receive on spot right now.
Well, this is a massive amount of work that you and Justin have been doing out in the desert.
Oh yeah,
This is
there's no help really.
Yeah.
Not alone all the glomming that I had to do.
Right. Now imagine an old Toyota pickup carrying these poles in the back of it.
Yeah, and then you have to remember, we have to dig them out of the ground half the time too.
Mm-hmm.
And they're 5 feet in, and they're heavy. They're about 400 pounds each. So yeah, we might have to go out and try to harvest some more, but we have, the insulators are all here. We have about, there's somebody that's got a quantity of these things that's holding for us. We have about maybe 2,000 or 3,000 insulators of the right type. The pins are a little more difficult, and also, unfortunately, these telephone arms are all drilled for wooden pins, and the carrier pins are steel, so you got to have this special wooden adapter, and they're not always that easy to recover, but I think we're doing okay on that. We got quite a few cases inside of this stuff, and we have this insulator storage yard from the big line that got taken down that brought me here, the 66-mile long one, because it really takes about a 25-mile length to do this right. We're just screwing around with a few thousand feet. It's not right, but that's all we got. So,
right.
But it should be, the receiving structure should be between 10 and 25 miles, and it should be an area that's at least 50 miles away from any kind of power lines. So these things used to exist in the desert, but they're, other than the few scraps that we've managed to secure and get, right away and all that, most of it's gone. So there is a couple of lines still standing that aren't in use that are you on? Yeah, there's several miles long. There's one that's about maybe 10 miles long or whatever. So when we get set up at it, we have a line truck, but we have absolutely no money at all to overhaul it or get it fixed up, and it's been sitting around for a long time. But we do have the line truck, and we also have the guy that originally operated it.
So that helps pull out poles or put poles in?
That, but that's $5,000 or $10,000, to do. We just got done, in the past 60 days, $3,600 has been spent on that pickup truck in maintenance and repairs. Because when you get something used for $2,000, you're married to a bigger bill. And so that truck's got around 250,000 miles on it, and the previous owners did not take care of it. So right now we're dealing with the, step-by-step total rebuild of the truck, because we can't have that thing screw up out on us 50 miles out in the middle of nowhere. That's not acceptable. It has to be able to run all the time. So it requires that higher level of reliability. There's no tow truck in some of these places we go. I don't even think the tow truck could get in there.
So what is this?
This is a long persistence phosphor oscilloscope, like I had at Landers for making the slow trace, like on the heartbeat, type thing. So this is a real nice Navy unit, and it's got that kind of CRT I need in it. And so this will be used for the seismoscope that shows all the micro vibrations, where you can see the little blips from coyotes and rats running around, and the tiny stuff, rocks cracking underneath the earth. This is the scope that will show that. It's rack mount, very well built.
So is that screen like the one on that radar indicator up in Spokane?
Yeah, it's the same type of screen.
So up in Spokane, we have one of these big units that's maybe 3 feet high by maybe 2 by 2 feet, and we need to get that down here, and that'll probably cost several hundred to put on a pallet and have it shipped down.
So I do have some other scopes that have those types of phosphors, but they're not really, they're in a raw form and they're not set up yet, where this one will just, it's a plug-in and work. So that was a good find. That came in with the O carrier equipment. and a lot of this other stuff. And this is the type of, this spectrum analyzer here is, it's been sitting in the rain in the junkyard for quite some time, and then somebody with limited sensibility stripped the power supply and lost the parts, but I managed to find some of the parts. But if anyone can find another one of these things, this is a very critical component in studying the Earth signals.
Panoramic telemetering indicator. I remember I was looking for these online and I couldn't find one.
Well,
references to it.
Yeah, eventually something. I hope something shows up. Otherwise, this is going to be a lot of work to restore. I mean, I can do it. So I got another one down here that supposedly works. You can see it down there in the back.
Yeah.
But the frequencies are a little high. It doesn't go down into the audio frequency. But then I have some really fancy ones over here that were donated. And these things are really good for finding UHF interference and using HF band studies and all that. So I'm pretty sure between all this stuff here, there's not going to be any problem having one that works. So this stuff needs to get up off the floor and go into the racks. That's kind of the next step. But the complication is we have to find the rack adapters for all these pieces of equipment. That's the holdup there. So all that stuff has to be, a little bit at a time, it has to be searched out on eBay, and it's a lot of stuff to do. You know, these are the carrier voltmeters that I prefer to use. This is more of the Wendover telephone stuff. Any of this Sierra Electronic Corporation, they made a lot of carrier telephone spectrum analyzers and selective voltmeters. They usually, rather than gray, they usually picked green or brown for their equipment, but that's the type of stuff we need to analyze the signals. We do have the fancy digital one to start with, so that's good, but sometimes the digital stuff just doesn't work out as well as the analogs. Let's see. Here in the pile. So these are the O carrier modules that I'm starting to see. Here I have all the necessary units. So it's an interesting, brilliantly engineered by Western Electric to do this carrier telephone work. So I'll have to, I got to start going through these one by one and get at least one set that works. So these are the sideband separators. And this is like the line driver. So and then the book has got junk everywhere. Where did I put the book? This one. When it's all together. So this is what goes in the cabinets on the poles normally. So these are the cabinets that we need. If anyone has any of these N or O carrier cabinets, we need these things to put the equipment in. Here's one complete unit. So this thing takes 4 telephone lines with the dialing and the ringing and composites them on one pair of wires and then demultiplexes them at the other end. So now there's one interesting thing about this O carrier stuff, which makes it even more relevant to what's going on here, is the O carrier system operates in the Alexanderson frequency band. So when you look at the frequency allocations on this thing, this is the OA system, is it operates from 2 kilocycles to 36 kilocycles. So an interesting feature of these things is they can actually be connected to the telluric transmission system. And one of the experiments I want to do, even though there's going to be a lot of Navy signals and other things that are going to interfere with some of the channels, the whole idea is the end engineering, I should say, the objective is to try to transmit an O carrier system telurically through the Earth, rather than the pair of wires that it was normally designed to be connected to. So that's going to be an interesting challenge. So as well as the seismic aspect of this, there's also the communications aspect. So that's what made this a valuable find. Most of the stuff is historic, and this is what connected to the facilities that we're now taking down, all the glass insulators and cross arms and wires. This was the terminal equipment for that system.
So right now here, there's a sewer problem where there's a drainage issue and the sidewalk is tore up outside, and the city is kind of giving some assistance. So
can't use any bathroom. There's no bathroom here to wash or
so
any of that stuff. So I'm really having a good time.
And so Justin is spending a lot of time dedicated to that project, because that sewer has to get fixed, and as soon as that's done, then he can get back to doing some building around the shop as far as putting up shelves and that kind of stuff. So we can
is beyond us. It's out of our control. So it's become a major public utilities effort. So there's no resources for a long time. So pretty much, then I guess we'll be getting back on getting the infrastructure. And here, because the weather's so bad outside, we can't really do a lot of line work. We were really fortunate that other day just to have that 1 or 2 day break where, you could go out and you could have Steve McGreevy come and connect his radios to it and all that.
Right.
But it's not like that outside right now. It's mud and snow, 29 degrees, massive windstorm came through yesterday, and everything's covered with dust. So
we can take a look at that bookshelf there.
Yeah, this was these are what are called the Bell System practices. So the diagrams of the setups of their carrier equipment and microwave facilities, and how the whole fiber optics thing evolved, and everything is all in these books. So you could actually feel there's so many popped up around here, and then some of the stuff was on GLOM runs with me and Steve Hills, and this oscilloscope was in a pile of debris in some place, and Steve came back with it, and we dumped it off here, and most of it was junk, but there was a working oscilloscope.
Right.
So that helped a lot. So it's all kind of coming together now that I got enough test equipment where I can at least start to do some experiments and fix things.
Okay. Can we take a quick peek in that room?
A good share of this stuff was supposed to be stripped. There was a bunch of equipment that was in storage on the coast, and when we went back to get it, we found out the building had collapsed and most of the equipment had been destroyed. Like this stuff here is all rotten out, and so
This is December 11th, 2015, and we're here at EPD Laboratories with Eric Dollard. And as you can see behind Eric, we do have there was a lab coming together with equipment and some experiments on the bench with the network system that's related to the seismic project. And if you haven't seen the video on that yet, that'll be on YouTube, where Eric goes into a lot of detail about what this is about. But anyway, we can see some of the equipment here. And do you want to kind of explain what some of the equipment is and how you...
Well, this is kind of a network test bench where I test the response of various transformers and coils. These are the things that I've stripped out of equipment so far.
All of these?
Yeah. And there's boxes of other things around. So this is kind of all the stuff that's being stripped. The strippage has produced enough components that now at least I can start to kind of throw some stuff together. So there's various pieces of test equipment that They came from different locations, and there's some people that have donated quite a bit more test equipment, which has helped. So
there's the
some of this stuff is from like Mark McKay, and then some of the stuff